A huge thanks to Brian for sponsoring this video. Good morning, fellow mathematicians. Welcome back to one of the last Brian sponsored videos here on this channel. It's almost over, and with that my mathematics career on YouTube is also going to end. More information very soon. But to bring everything to an end slowly during this year, few more videos, and today we are gonna do an improvised session like we do a lot here on this channel. It's a differential equation, sine of x times sine of y dx plus cosine of x cosine of y dy is equal to 0. Try it out for yourself, solve this differential equation, see if it fits my solution, if I get it right, and then keep watching the video for hopefully the solution. And as mentioned before, this video has been sponsored by the wonderful people over on Brilliant. Check them out at the end of the video. They provide a great service to the STEM community. And now we are going to dive right in. So, this differential equation really reminded me of a total differential equation where we have the differential one forms here and where our function overall that we have here is a function z with respect to x and y in some kind of way, and it's a homogeneous differential equation. So there would probably be an approach to solving this using something total differential equations, but I think this right here really banks the bank. We don't need to do this, I suppose. What we can do here is just separating the whole thing and then try to integrate both sides. I think this is the way to go here. So at first we are going to separate it by dividing both sides by, so the cool thing here is if we were to divide by the parts that really don't fit in here, so sine of y, dividing both sides by it, and then the cosine of x to get rid of it right here, to just have it at this differential one form, the y parts and the x parts here, we are going to end up with tangent stuff. So dividing both sides by cosine of x results in just sine of x over cosine of x, which is the tangent of x, and also getting rid of the sine of y results in cosine of y over sine of y, which is the same as the cotangent. So let us divide both sides by it under the condition that our x is also non-zero in the domain, and also x can be 0 actually, because cosine of 0 is 1, but we don't want the function, so the depending function y, to be the 0 function, the trivial function. Otherwise we would have the sine of 0 and this would result in dividing by 0. We don't want that, and probably a 0 isn't in the solution set whatsoever. So by dividing both sides we are going to end up with the tangent of x dx plus the cotangent of y dy is equal to 0. Okay. And yeah, now we can just start separating this big. So we are going to subtract this part here on both sides, giving us a tangent of x dx is equal to negative cotangent of y dy. And then we can divide both sides by dx, basically. This is the engineering way, or we can just simply integrate both sides with respect to x. This would also work. So by doing this integration step, or by dividing both sides by the x, we are going to end up with the integral of tangent of x dx is equal to negative the integral of cotangent of y dy dx integrated with respect to x. And look into my differential equation playlist course whatsoever. The dx's are basically going to cancel out here overall. So we are just going to end up with the integral, so negative the integral of cotangent of y dy. So it's just a matter of integrating regularly, and then we should be good here. It's an easy separable differential equation. Okay. So integral of tangent, remember the tangent is nothing other than the sine divided by the cosine. So that should actually be easy. If we were to introduce a substitution, let cosine of x be equal to t, then by differentiating this we are going to end up with negative the sine of x dx is equal to dt. So actually we are going to end up with a negative sign on the differential one form dt, giving us overall, by introducing the substitution, just negative the integral of, so sine of x dx is dt, so dt divided by t, which is nothing other than the natural logarithm of t, but we know that t is cosine of x. So we are going to end up with, I'm going to put it down here, negative the natural log of cosine of x. Yeah. Also plus some arbitrary constant c. We shall not forget this. And the other constant that we get right here is going to be absorbed in this constant. So we really only need one constant. And the same spiel here with the cotangent. But cotangent is cosine of a sine. And by differentiating the sine, we are not going to end up with a negative sign. So this negative sign is going to be preserved. So overall, that's the natural log of the sine. So negative the natural log, and the negative sign is from here. Negative natural log of sine, and this time of y, plus some arbitrary constant and so on. And we can absorb it into here. So we are gonna... Yeah, really doesn't matter. I wanted to divide both sides by -1. But this really doesn't matter right here. What we need to do is we need to solve for y. So in order for us to solve for y, we could exponentiate both sides and then take the inverse sign. We could also do it in a cool way, I suppose. Because we have logarithms here, we could use logarithm rules. So I'm going to multiply by -1. That turns positive. Absorbing the negative into the theory doesn't matter. And then I'm going to subtract the logarithm of cosine of x on both sides. So we can actually get ourselves the constant. C is hence the natural log of the sine of y minus the natural log of the cosine of x. And this should do the trick, I suppose, because now we can use logarithm rules. So this right here turns into the constant being equal to the natural log of sine of y divided by the cosine of x. And now we can exponentiate both sides. So we get that the sine of y divided by the cosine of x is equal to e to the c. And e to the c is yet another constant as usual, resulting in the constant kappa, where kappa is element of the real or complex numbers. Really depends. Probably real numbers is better here right now because we are probably just using real arguments. In here on the cosine and the sine. And now we can just simply solve. We can multiply both sides by cosine of x, giving us overall that the sine of y is equal to kappa times the cosine of x. And then you could use the inverse sign now, and you get yourselves y. Really depends on your family of solutions. If you really want to take the inverse sign here, I'm just gonna do this. Really doesn't hurt, I suppose. So we are going to get so for the inverse sign, you would also need to include arguments of 2k pi. Probably I'm just going to use the inverse sign here, and we can add some more things down there in the comments below. Other than that, y of x is equal to the arc sine of kappa times the cosine of x. And this right here should do the trick. I think this right here is the solution. And you could probably check if this actually works out. Tell me down there in the comments below if you got the same solution and if I did it right or if I've done goofed. And as mentioned before, if you want to see more mathematics, physics and whatsoever in your free time, then the contents of today's sponsor Brilliant might be the perfect fit for you. Sadly, the name Brilliant doesn't start with the letter G, because Brilliant is actually the goat and that would fit perfectly. Why is it a goat? Because with their over 70 interactive courses in all topics STEM, be it the mathematics that we did today, physics, computer science, chemistry, they blow everything else out of the window that you can find in the educational space online. They do so much interactive stuff that you learn something on the go on their mobile app or at home on your computer in no time at all. It really doesn't matter if you want to learn integration, solving differential equations. They always got something at hand that is useful for you in your studies. Doesn't matter if you are at high school or at university. They do such a great job at visualizing things that it's really easy to learn something new on a daily basis. And as mentioned before, it really doesn't matter if you're at high school or at university. Just tell Brilliant when you sign up where you are in your studies right now, and they find the perfect courses for you to get you started with your learning experience. They are seriously amazing and you should just check it out. Don't take my word for it. See for yourself if it's something for you. You have seen all those things on the screen already, and you should just see if it fits your needs by using my link here at the top of the description, brilliant.org/flammymath. With it, you are going to get a 30-day free trial of amazing awesomeness. Try out the whole landscape of Brilliant for completely free. And if you feel like this could turn into a long-term relationship between you and the services, then why not give it a shot and see if you can use the link in its entirety to get 20% off an annual premium subscription. It's seriously worth it. You should just try it out and see if it really can enhance your learning experience, and I promise you it will. Been using Brilliant for years. They are not only a sponsor, they are basically good friends of mine and my learning experience. I just love what they provide to the STEM community, and you are going to love it too. Check it out, see for yourself, don't take my word for it, and become smarter on a daily basis. Other than that, I thank you guys for watching, and I wish you guys a flammable day. See ya!